Problem number 13. So we're told that T of xy is temperature, and at the origin, we're told that T is increasing at a rate of 3 degrees Fahrenheit per mile in the direction of the vector j hat, and it's decreasing at a rate of square root 3 degrees Fahrenheit per mile in the direction of negative I hat. So what we want to do is that we want to use this information to tell us what the gradient is. So our ultimate goal is to say, what's the gradient of t at the point 0, 0? And so the thing to realize here is that the gradient of t is the vector that's the partial derivative of t with respect to x and the partial derivative of t with respect to y. But this first piece of information here, t is increasing at a rate of 3 degrees Fahrenheit per mile in the direction of j hat. This is telling you that the derivative, the partial derivative of t with respect to y in the j hat direction, the partial derivative of t with respect to y is going to be 3. So that just tells you that the second component here is 3. Now, the other piece of information here is that we're told that t is decreasing at a rate of 3 degrees Fahrenheit per mile in the direction of negative I hat. If you went instead in the direction of positive I hat, t must be increasing at a rate of 3 degrees Fahrenheit per mile. That's how these things work. You change the direction. You change the direction by 180 degrees, pi radians, and you exactly change by a negative sign. Your increase or decrease. Decrease becomes increase and vice versa. So this information tells us right here that dt dx at the origin must be square root 3. And so this right here, this is our gradient at the origin. Let me just point out, if you're suspicious of this, let's just do directional derivatives in these directions here with this gradient. The directional derivative in the direction of j hat of t at 0, 0 is the gradient dot product with j, and this is 3, just as we expected. And then the derivative in the direction of negative I hat at t at 0, 0 is the gradient dot product negative I hat, and this is negative root 3. That's a root 3 degree decrease. Exactly what we wanted. Okay, so part A is done. Here's our gradient. Part B, write a unit direction vector v with negative first coordinate in which the rate of change of the temperature at the origin is 0. So here is our gradient recopied. We want our vector to be a unit vector, negative first coordinate, and we want the rate of change in the direction of in this direction of the temperature to be 0. So we want the directional derivative in the direction of v of t at the origin to equal 0. So what I'm going to do to solve this problem is that I'm going to come up with a vector that does this, and then we're going to modify it so it checks the first two conditions. So what I'm looking for is directional derivative. We want the gradient dot product our vector to be 0. We want our gradient dot product this vector to be 0, so the v1 and v2 are unknown. So root 3v1 plus 3v2 is equal to 0. So here is a possible answer for V1, if V1 and V2. V1 could be root 3 and V2 could be -1. So check for yourself that if you do this dot this, you get root 3 times root 3 is 3, plus 3 times -1 is 0. So this has the property that the directional derivative in the direction of this vector is 0. Now, how do we get something, so it's a unit vector with a negative first coordinate? Well, realize that if we multiply this by -1, this dot this is still 0. This dot this is still 0, so now we have a negative first coordinate. Finally, how do we turn it into a unit vector? The magnitude of this is 2, so all we have to do is divide the entries by 2, and we are done. So here is our answer.